This video is intended to show you how to solve a problem about overcoming friction. I'm not going to lie, overcoming friction problems can be challenging, but if you draw the free body diagram, label the vectors in the free body diagram, and think about which vectors are going in the same directions, then the problem will work itself out. The problem I gave you is number 1 from page 141. A student pulls on a rope attached to a box of books and moves the box down the hall. The student pulls with a force of 185 newtons at an angle of 25.0 degrees above the horizontal. The box has a mass of 35.0 kilograms, and coefficient of friction between the box and the floor is 0.27. Find the acceleration of the box. So I've drawn for you a free body diagram. I've got my normal force, I've got my gravitational force, I got my frictional force, and I also have a force applied. And I know that force applied, according to the problem, is going to be 185 newtons. Since that applied force is at a 25-degree angle, I can resolve that vector into its x component and its y component. And so I can call this force applied in the x direction and force applied in the y direction. And this will be the 25 degrees. So I can see here that the gravitational force, normal force, and force applied in the y direction will all add together to be nothing, 0. And that's because the box is sliding across the floor as opposed to moving up and down. So I can find the normal force by using the fact that those three vectors added together will have the sum of 0. So I'm going to start by finding the force of gravity of the box. So the force of gravity is mass times gravity, which will be the 35.0 times 9.8, which will get me a force of 343 newtons. I can also resolve the applied force into its x component and its y component. So I can say force applied in the y direction is going to be the applied force of 185 times the sine of 25 degrees. And I can say the force applied in the x direction is going to be the 185 cosine 25 degrees. Solving these component vectors out, I find that the force applied in the y direction is 78.2. Force applied in the x direction is 168. These are all newtons. So putting these on the diagram, things will start to make sense. Force applied in the y direction, 78.2. Force of gravity is going to be the 343. And I don't know the normal force because it's not perfectly resting on the surface because I've got this applied force now. And my goal is to find the normal force. So I know that the normal force plus the force applied in the y direction minus the gravitational force is all going to equal 0. I know that because if I look back at my free body diagram, these three vectors all are in the vertical direction. And I know, again, that the box is not moving up and down, so the net force vertically must be 0. So I can rearrange this equation now to say that normal force is going to be the gravitational force minus the force applied in the y direction, which will get me the 343 minus 78.2 So my normal force would end up being 265 newtons. So putting that on the diagram, 265 newtons here like that. What that's going to enable me to do is find the frictional force. So the frictional force, using this frictional force equation, coefficient of kinetic friction times the normal force. Coefficient of kinetic friction was the 0.27. Normal force is going to be the 265. And so my frictional force is going to be 71.6 newtons. I'm going to put that on the diagram, and that's my first horizontal vector. 71.6. Actually, we have the force applied in the x direction, which is the 168. Now, I do know that the box is moving to the right, let's say, in the direction of the applied force. So if I add the applied force in the x direction to the frictional force, its negative value, I should be able to get the net force of the system. So the net force is going to be the force applied in the x direction minus the frictional force. Again, that's going to be the 168 minus the 71.6. And I'm subtracting because frictional force is acting opposite of the applied force. And I will find that that value renders a force of 96.4 newtons. We are almost done. Remember, the whole purpose of the problem is to find the acceleration. So force net equals mass times acceleration. Divide both sides by mass. I will end up having my net force of 96.4 divided by, remember, the whole entire mass of the crate was a whole 35 kilograms. That should get me my acceleration, which will render a value of 2.7 meters per second squared. Yes, it does seem like a long process, but remember, all we're trying to do here is figure out what vectors go in the same direction and will be added together. Vertical vectors all get added together. Horizontal vectors get added together. Always draw your free body diagram, and then when you have the free body diagram, label the components and see what's going to add together or subtract. So this problem will help you solve the other problems on page 141. There will be a second video about an object that is resting on a ramp, which there will be a little twist to that, but that'll be a second video. So good luck with these problems.